Greetings, ladies and gentlemen. We had a request to do a mechanism from Fall 21 Test 3, Part 4. And here it comes. And what we have going on here is a little review reaction from Chapter 16. What we're doing is we're making a cyanohydrin. And that's from ketone in this case, ketone and hydrogen cyanide. First step, we would protonate, not a strong acid, but once you have one molecule, that's all you need, even though the equilibrium is not favored. And let's do some judicious circling of R groups here. Everything except for the ketone equals R. And we can use this symbol here. You got to show two things coming from R. And we got an H, a plus, a cyanide. That's a strong nucleophile. And that's the reason this reaction happens so well, even though pKa is not on its side. Because that reaction is irreversible. Once you get there, it's not coming back. And Le Chatelier says, once you remove this product from this bad equilibrium, you have to make more. So it doesn't matter if you only made one. Okay, here we go. Cyanohydrin, what's going on? No mechanism. Reagents. Nitrile becomes an amine. If you want to pay attention to what's new here, here it is. Two new H's. And two more new H's. That's four new H's. Each one of them can come from H2 and PT. Alternatively, you can use NaBH4 followed by HCl. They both work to reduce a nitrile to a primary amine. And then we're setting up for my favorite mechanism. I see sodium nitrite. I'm thinking tiffanodiamyana. Tiffanodiamyana. And what happens here is we have an acid-base reaction with nitrite and HCl, which is in excess. And we generate nitrous acid. Look forward to generating nitrous acid on your test at least one time, probably more. And then we're going to do a two-step process where red's first, blue is second. And that's going to have another HCl. Not a lot of room over here. We're going to dehydrate nitrous acid by protonating it first, and then eliminating the water. And there's water. And we've made N triple bond O. Nitrosyl cation. Amines love nitrosyl cation. And this time we're going to circle everything up to, but not including the amine. Call it R prime. R prime. The amine on that molecule attacks the nitrosyl cation. We're just wandering over to the left here. We have R prime. Yeah, I didn't grab the CH2 today. So that's CH2, N with two H's. Now attached to N double O. And don't forget that's a plus on the ammonium ion. Now it's time for tautomerization. Remember, you have to end up with an N triple bond to N. Diazonium ion. We're not there yet. We're nowhere near. We're getting closer. You need both the base and the acid conjugate partners. Oh, that didn't work. No double bonds to H ever. There we go. The base deprotonates the ammonium. And as you tautomerize, you resonate and protonate. And that's your tautomerization. Got a double bond to N. It has an OH poised to leave. You're going to need to do the same, almost the same thing again. This one's an elimination, but to do an elimination where water's the leaving group, under acidic conditions, you have to protonate it first to make it a better leaving group. Trying to get a little more room here. There we go. Protonate first. Cl minus comes in, does an elimination after that. Oop, don't go that way. Keyboard way over there. Let's see, where am I going? So pick up the Cl. Triple bond here. Leaving group leaves. You do have to draw out your molecule now because the R group is about to change. See, the ring got bigger inside the R group. So I'm gonna need 2 copies of this thing. It's okay. After you've drawn them, you don't have to draw any more intermediates. And what we're gonna have here, I'm gonna draw my normal benzene. Work on the consequences later here. And starting in the meta position, we have the other ring. Cl's in the way now. And what else we got? The ketone. Oh, we don't have the ketone. I made my ring bigger already, didn't I? Yeah. Power of positive thinking. It's a ring size 5 with an OH here and a CH2 with an N triple N here. That's what it looks like. I need 2 of those. I won't copy paste it because you don't have that luxury on your exam. So these are equal to each other. Ring size 5 down here. Dimethyl OH CH2 NHN triple N. There, I got 2 copies. And now it's about rearranging because we have an exceptional leaving group. If you rearrange this bond here, what happens? Rearrange that, leaving group leaves. There's one of your nitrogen gases. You're gonna get a carbocation right here, aren't you? A lovely carbocation resonates with the old lone pair. And instead of drawing that intermediate, why don't you have your base grab the H? Sigma becomes pi. That's after the rearrangement or before. I really don't care. I could see this in one color and I don't care. So I'll do it in one color. CL minus grab H. Sigma becomes pi, which causes the rearrangement to happen. Let's do it. That's not for that product, is it? That's not going to put a CH2 in front of the benzene. This is for the other product. First. Oh, yeah. Okay. Fix my anion. The other one just go the other direction. Cl minus grabs the same H. Sigma becomes pi again. Instead of breaking this bond adjacent to where you made a new bond, break this bond. And yeah, there's your CH2 right off of the ring now. And there's your leaving group leaving. And that makes the second product. Lovely little mechanism. Gets ring expansions going and everything. All right, not too bad. You know the Tikhonov-Demyanov's coming. And we'll come back with part C. Be ready for the video, part C. And adios.